All right, guys, let's go through solving equations with variables on both sides of the equation. So we're still going to start off by drawing our line, keep our balance. Our goal here is still to have variable equals answer. So since there are variables on both sides, the first thing I would always do is move that variable so that we only have variables on one of the two sides of our problem. And my suggestion to you would be to always move the variable that has the smaller coefficient. It doesn't really matter, but that usually keeps you from having to do too many negative numbers, and that's just one less thing for you to worry about is all those integer rules. So here, 3x is less than 4x, so I'm going to move that. When I say move it, I'm not going to just divide by 3. I'm not just trying to get rid of the 3 that's with the x. I'm trying to take that whole term and move it onto the other side so all my x's are on one side. So here, since this is adding 3x, I'm going to subtract 3x from both sides. So over here, 3x minus 3x, that cancels, and I have 5 left over, equals 4x minus 3x leaves me just x plus 6. And now that's a really easy problem for us to solve, okay? So now subtract my 6, subtract 6, x equals, remember this is going to be 5 minus 6. If I were to keep, change, it's really adding a negative, so different sign subtract. This will leave me with negative 1. So x equals negative 1. Okay, next problem. Again, I would move the 4x first, so minus 4x minus 4x. And I get 9x minus 4x leaves me 5x plus 5 equals. On the other side, those cancel. I have 15 left over. Then I will subtract my 5. This is just a normal two-step equation, right? So get rid of your ribbon and then your Allen wrap your package. So get rid of your constant and then your coefficient. So I have 5x equals 10 left over. Divide by 5 on both sides, and I get x equals 2. And that would be my answer. Okay. I would get rid of my smaller coefficient first. So why don't you go ahead and do that step? So we're subtracting 3m from both sides. I have negative 8 equals 5m minus 3m is 2m plus 8. Then we would get rid of this 8 that's over here, the coefficient, or sorry, the constant that's with your variables. So minus 8 from both sides. I have 2m left over on the right. Negative 8 minus 8, or keep, change, negative 8 plus negative 8 is negative 16. And then divide by that 2. So m equals negative 8. Don't forget your sleeping dog. Negative divided by positive gives you a negative. Okay, let's look at this one. Why don't you go ahead and try it? Okay, so I would get rid of the negative t first by adding t to both sides. So over here, that's canceling. I get 9 equals, t plus t is 2t plus 5. Now that's a normal two-step equation, so subtract 5 from both sides. 2t equals 4, and then divide by 2. So t equals 2. All right, let's look at this one. So I'm going to subtract my 7y. Subtract 7y. So I get negative 7 over here because those cancel. Equals, and then 7y minus 7y, those cancel. Equals 13. Negative 7 equals 13. Well, hopefully you're like, no it doesn't. Negative 7 does not equal 13. And I agree with you. So here's the thing with this problem. When I solve it out, it gives us these two numbers that are not equal to each other. When this happens, this is a special type of problem. our actual answer that we would write would be no solution. You will actually write those words, no solution. And here's why. There's no number that I could put in for y to make this problem true. Not 0, not 1, not -17, nothing. There's no numbers that I could possibly put in for y that would make this a true statement. Okay? If we look back at the original problem real quick, I could tell you, just looking at the original problem, that this was going to be a no solution. And the reason is right here. I can see that our two coefficients were identical, 7y and 7y. So what that means is when I go to move one to the other side, it's going to cancel out. Okay, that's important, but that's not the only reason. Okay, those have to be identical, but then when I look at my constants, those are different, right? So when these cancel out, it leaves me with these two different constants left over, and that's why this turns into a no solution. And think about it, if I start off with a number, subtract 7 from it, and then if I start off with that same number and add 13 to it, there's no way that those could be the same answer at the end. There's no number that I could subtract from and add to and it end up being exactly the same. So this is a no solution problem. Okay, go ahead and solve this one. This one's just a normal two-step problem. You can do it. So we should start by adding 22 to both sides. I get 4h equals 0. Here's the problem. A lot of people get to this step and they're like, oh, no solution. This is not a no solution. We haven't finished yet. So if I divide by 4, h equals 0. That is an answer. 0 is a number. That's an answer. This is not a no solution. The solution is 0. Be really careful. Those are not the same thing. Okay, next problem. You go ahead, pause the video and you do it. Okay, so I would move that -3r. Remember, if you like box your terms, that's a -3r or a -3r. So since it's subtracting 3r, I'm going to add 3r. Add 3r. So over here, I have 3r minus r, because remember, I'm like boxing my term there, or +3 plus -1. That's fine either way. I get 2r minus 3. On the other side, those cancel, so equals 1. Add my 3. So 2r equals 4. And then divide by 2 on both sides. R equals 2. All right, next problem. Subtract p. I get 7 equals 6p minus 13. Add 13. 7 plus 13 is 20 equals 6p. And then divide by 6. Divide by 6. You could do this with decimals, or I think it's just easier just to make it a fraction. So I have 20 over 6, and if I simplify that and make it a mixed number, 6 comes out of 20 3 times, because that's 18, which leaves me 2 left over. 3 and 2/6 is just the same thing as 3 and 1/3, so p equals 3 and 1/3. It's okay if you go decimals. This is a repeating decimal, so that's why I kind of just left it as a fraction instead. All right, for this one, we do need to do this distributive property. So distribute. 2 times 2x is 4x. 2 times 1 is 2, so minus 2 equals 4x minus 2. Okay, go ahead and move that variable over. So minus 4x minus 4x. 4x minus 4x, those cancel. I get -2. On the other side, 4x minus 4x, those cancel. I get -2. This is not a no solution though, because look at what's different. This time I have -2 equals -2. Well, guess what? Yes, it does. -2 does equal -2. So this time it's not no solution. This is another special one called infinite solutions. So what that means is any number that I put in for this problem would be correct, any number that I choose, okay? Because they are identical. If you look back here, I'm gonna, again, kind of erase this one step, just so you can see. Right here, I had 4x, so my coefficients were the same. I had -2, -2, my constants were the same. The two problems on the either side of the equal sign are identical. Anytime they are identical, same signs, same numbers, everything, that's infinite solutions, and any number I plug in would make it true. Okay, go ahead and distribute. So b plus 9 equals 4b plus 66. If I subtract b, I have 9 equals 3b plus 66. Subtract 66. 3b equals, different sign, subtract, so 66 minus 9, borrow, gonna give me 58. Oh, just kidding, 57. I don't know why I made that a 17. What in the world? Sorry about that. 57. And then I will divide by 3. 57 divided by 3. 3 comes out of 57 19 times exactly. You could do the division off to the side if you need to, and that's just fine. I am going to just do that. Okay. All right, next one. Go ahead and solve it. I would add 4g to both sides. So I have 12 equals 5g plus 12. Subtract 12. So I have 5g equals 0. Keep going though, this is not a no solution. Divide by 5, divide by 5, and g is equal to 0. That is a solution. Last one, go ahead and distribute. 6w plus 12 equals 6w minus 15. Already right here I can tell what this answer is going to be, but if you can't, we can just keep solving. So minus 6w minus 6w, I get those cancel, so 12 equals, those cancel, negative 15. 12 equals negative 15? No, it does not. So since they are not the same, this is a no solution. Okay. So finally for our rules, real quick. Infinite solutions, remember this is when the two problems are identical. Problems are identical, everything about them. They don't have to start off identical. They don't have to start off the exact same, like you could have to distribute or combine like terms, but they will be identical once you kind of do that stuff. For no solutions, this is where the coefficients are the same, but the constants are different. Okay. And finally, one solution. This is actually where we start off with our coefficients that are different. Coefficients are different. Okay. If you want to have an example of each of these, for infinite solutions, it would look something like 2x plus 3 equals 2x plus 3. There's an example. For our no solution, that would look something like 2x plus 3 equals 2x plus 5. And then for a one solution, it would be something like 2x plus 3 equals 4x plus 5. Okay? And that's it, guys.